Dynamic braking resistors are used on AC variable frequency drives to dissipate energy that is produced in the motor as the drive provides braking torque to stop. Dynamic braking lowers the wear of friction-based braking components and reduces energy consumption. For example, while a locomotive train is coasting, the engineer, using a controller similar to a throttle, energizes the traction motor field, causing the motor to act as a generator. The resistance of the motor field helps slow the train. The electric current generated by motors in dynamic braking mode is dissipated as heat in banks of resistors. The dynamic brake resistor features a large thermodynamic heat capacity, enabling the resistor to absorb a lot of energy without causing the temperature of the resistor element to exceed the operational temperature rating. To calculate the correct resistor size, you need to know the peak power time on, time off, the intervals of the pulses, applied current, and the voltage. Ideally, you calculate the mechanical energy involved in each stop, which will be the sum of the kinetic, rotational, and potential energies, less any friction losses, if significant, and less the electrical losses in the motor system. Knowing the stop energy and the duty cycle, you can calculate the average power into the resistor, which for most duty cycles will be the right power to begin testing. When the stop time is short, you may need to consider a resistor with a larger thermal capacity to prevent overheating. To calculate the maximum dynamic brake resistance value of a small motor, follow these steps. First, locate the power level of the motor in unit of kilowatts. Call this value P. As an example, P is 1.25 kilowatts. Then, determine the motor efficient rating. Call this value F. F is a constant between 0 and 1. As an example, assume F is 0.85. Find the operating voltage, or V, for the braking system. As an example, assume V is 800 volts, which is standard for most dB systems. Then, calculate the dB current level, or I, using the formula I equals P times 1000 times F divided by V. The number 1000 is in the formula to convert the kilowatts to watts. Using the example numbers, I equals 1.25 times 1000 times 0.85 divided by 800 equals 1061.5 divided by 800 equals 1.328 amps. Finally, calculate the dB resistance using the formula R dB equals V divided by I. Continuing with the example, R dB equals 800 divided by 1.328 equals 602.4 ohms. Select a resistor bank that has all of the following: a resistance value that is less than the value calculated, RdB in ohms, a resistance value that is greater than the minimum resistance and power value. Ohmite offers multiple resistors for dynamic braking applications. For details on the different series of resistors, watch our Dynamic Braking Resistor Summary vodcast. For more information about Ohmite, visit www.ohmite.com or follow Ohmite on Twitter and Facebook.